Lesson 19.1 and 19.2 have to do with understanding quadratic functions and graphing them with translations. If you'd like to pause the video at this time to copy this in your notebook, otherwise go ahead and continue. Quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. And it's a polynomial with a degree of 2. Please copy this down in your notebook and I'll give you an example. Notice the red example has some negative signs in it. It's still in this form even though it's a minus sign instead of a plus. It's just a negative 4 instead of a positive 4. The b does not have to be positive, neither does the c, neither does the a. One of the last examples is going to be something like this. Negative 4x squared plus 3x minus 15. Any of these examples are in the standard form. The shape that a quadratic function forms is called a parabola. Again, go ahead and pause this to write this down, this example in your notes. And again, you can always pause or skip ahead in these videos depending on what you need. Here are a couple real-world images of parabolas. A roller coaster, obviously, the arch, and the famous arch of the McDonald's sign, the arch that dolphins make when they jump out of the water and go back in, and of course a banana. Now about the domain of a parabola. Even though it doesn't look like it, it looks like it's going to go straight up forever, never to negative infinity, but it does eventually get further and further out. It doesn't look like it, but just so you know, the domain of any parabola, whether it's facing downward, it's got a negative a, and I'll show you that in a minute, or facing upward, the domain is negative infinity to positive infinity. The domain of any parabola. The range, however, is different. It is limited. On an upward facing parabola, positive a, you've got a low end, that's your bottom end, it cannot go below that. And your top end is going to be infinity. If you have a negative a, that means it flips upside down, your top end is going to be this point right here, and your bottom point is going to be negative infinity. On the left, the low end, remember we start with our low here and go to our high. Our lowest point is negative 9, that's going to be the vertex we'll talk about in a minute, and the right side, the high side, goes to infinity. The low on this end is negative infinity, and the highest point it can reach is 9. And again, this is a bracket on 9 to show that it can include 9 here, and a bracket on negative 9 to show that it can include negative 9 as well. Continuing, the parts of a parabola are the x-intercepts. This is the point at which the parabola intersects the x-axis. This one's at negative 2, this one's at 4, this one's the upside down one's negative 4, and this one's at 2. There is a possibility, however, that the parabolas will never intersect the x-axis. Like this purple one's above it, it never will intersect it. And this one below it, the blue one, will also never intersect the x-axis. We'll talk about those later when we get into parabolas a little deeper and solving them. The other part's the y-intercept, obviously, where the parabola intersects the y-axis. On the left, negative 8. On the right, positive 8. The next is the vertex. It's the point at which the parabola turns directions. It's the peak or the very bottom of the valley. In the example on the left, we have 1, negative 9. That's the vertex. And on the right, we have a negative 1, comma 9. That's the vertex. It's the actual point. And the parabola either has a maximum, which is the highest point. This is going to be a max for a one that flips upside down, or a negative a. And then you have a minimum over here of a positive a parabola. Now the x value of the vertex is going to be also the axis of symmetry. It's the line that separates the parabola into two equal parts. If you can see here, this line that is technically x equals 1, it's a vertical line, separates the parabola into a mirror image, and this line, x equals -1, is the axis of symmetry for the parabola on the right. And now to graph quadratic functions, we're going to start with this, which is called the parent function. Okay, f of x equals x squared. I'll explain that a little more in a moment, but for right now, go ahead and open up Desmos on your computer or on your phone. Once you open up Desmos, just type in x squared. You don't have to, you can, if you would like to, put y equals f squared, or f of x is equal to x squared. Doesn't matter which way you do it. Just entering x squared will give you the parabola. At this point, we need to identify the domain, the range, the x-intercepts, y-intercepts, vertex, min-max, and the axis of symmetry. On this first one, the parent graph, the domain, again with every single parabola, the domain is -infinity to +infinity. The range, however, has a limit. It stops here at 0. That's my low point, and my high is infinity. My x-intercept, y-intercept, and vertex are all the same. The x-intercept 0, 0, the y-intercept 0, 0, and the vertex is 0, 0. That's why the parent graph, this is called the parent graph. It starts at 0. It's just the basic graph. It has a minimum because that's the low point, and the axis of symmetry is the actual y-axis, which is x equals 0. This part in the middle here, we're not going to do that. That's when you graph it by just plugging the -2 into the equation, getting the x value, and plotting it yourself, which is a little bit more difficult and less accurate than doing it on Desmos. Now for this next one, we're going to put 1/2 in x. You can use the decimal version, 0.5 x squared if you'd like to, or put in 1/2. I'm leaving the parent graph because I want you to see what happens to this function because of this. If you can see the a value in this quadratic function, you'll understand a, b, and c here shortly, if you haven't already. 0.5, it makes the graph a little wider. The domain's the same, the range is the same, the x-intercept, y-intercept, and vertex are the same as the parent function. The minimum's the same, the axis of symmetry is the same. It's just a little bit wider. So leaving these two here so you can see, again, this is my parent graph, the red one. The green one's going to be the 0.5 x squared. Go ahead and graph a -2 x squared. You're going to see what happens when you just punch in -2 x squared. Okay, you notice that it got a little skinnier than the red one, okay, because of the 2. It got fatter with a smaller number in front of it. The negative sign flips it upside down. So now we've got a maximum instead of a minimum. Now, because we have a maximum, our range has changed. The low end is -infinity, and this time the top end is 0, so we've got a bracket. The domain's the same. The x, y-intercept, and the vertex also remain the same, as does the axis of symmetry. The only thing that changed was this now became a max, and the range changed open downward. This is our last example before heading into 19.2 and doing the shifts. And you're going to say, well, Lentz, does it ever get off of the origin? And if I didn't expand it, there's nothing else here. But if you look now at this function, it's actually got some more meat to it, some actual numbers. So go ahead and pause Desmos and enter this next one into Desmos. And when you enter this next one into Desmos, you actually see we have an actual, real, live variation here of something that's off the, okay, we've got our x-intercepts now are -5 and 1. We've got our vertex down here. Our vertex has changed. Oh, that's not the vertex. I'm going to have to erase this one to get the actual vertex. There we go. The actual vertex is -2, -9. Put that because that's a point, -2, -9. Now it opens upward, so that's going to be a minimum. Our axis of symmetry is going to be the x value, the x value right here, which is -2. It's just going to be x equals -2. That line's going to go straight up through, splitting it in half. The y-intercept, we come over here to the y-intercept, and the y-intercept is -5. Okay? And the range, again, the bottom end is going to be -9, the top end is going to be infinity. As with all of them for the domain, it's negative infinity to positive infinity. Again, pause the video if you need to, or rewind to go through that. These dots over here are just the intersections with the other graphs, and as soon as we eliminate those graphs, we can just see the x-intercepts, the y-intercept, and the vertex. Now, talking about forms of a quadratic function, the first form is standard form, which we just talked about here. The second form of a quadratic is the vertex form. So take a second and copy down these notes real quick, and I'll explain what we're going to do here in a second. All right, this A right here is from our standard form. It's going to determine whether the function faces up or down, whether it has a minimum or maximum. Our x value in this becomes our h. Okay, this is going to be our x coordinate is our h. Now remember, it's the opposite sign from the equation. So if we had a vertex of 3, 4, okay, our vertex form would be, we wouldn't have an a unless we had one on there. We'd have to know it, but that's from our standard form. It would just be x minus 3 squared plus 4. If we had a different one, let's say we had the axis, or the vertex was a negative 2, negative 2, negative 4. Then our equation would look like this. It'd be x plus 2 squared. Remember, the h is going to be the opposite sign from what's in the equation. And then our k is going to be the same. So if it's a negative 4 in the y-coordinate, our k is going to be negative 4. If it's a positive 4 in the y-coordinate, our k is going to be positive. We experienced this when we talked about the form of absolute value functions and the shift of those v's. I gave you the similar vertex form when we did absolute value functions, so hopefully it's going to kick that into gear. The k, again, your y-coordinate, is the y-coordinate of the vertex, and again, that doesn't change. If it's negative here, it's going to be negative here, and positive here, it's going to be positive here. Now remember the shifts. I told you we were going to experience this later when we get to quadratics. The shift that comes from the inside is going to go left and right, and then the shift on the outside is going to go up or down. So looking at this here, go ahead and copy this down in your notes. This tells us what happens to from the parent function. We'll talk about parent function in the vertex form here in a second. So we're going to shift up k units or down k. Now notice, if it's positive here, we're shifting to the left because remember, it's the opposite sign here. So if it's a negative 3 here, it's going to be a positive 3 over here. If the vertex is a negative 3, it's going to be a positive 3. That's why we're shifting to the left. And if this, remember, it's opposite. If it was a positive 3, it would look inside here as a negative 3. That's why we're going to the right. Remember, the h is always the opposite of the sign in the vertex. This is going to be a reflection over the x-axis. We'll talk about that in a second. Over the y-axis. And then a, if it's greater than 1, it's going to stretch it by a factor of a. And if it's less than 1, it's going to be a vertical shrink. And we'll talk about those when we start playing around with those in Desmos. Go ahead and finish copying this down in your notes and resume when you're ready. Okay, now we're going to talk about shifts from the parent function. Remember, the parent function I've already entered over here. It's the red one. And on the left side, it's in blue. Sorry, I should put it in red. There. Now we're going to describe what happens to this next graph here. F of x equals 2 times x minus 1 squared plus 4. So before we graph it, I want you to take a look at these two numbers. Our h is going to be a 1. Okay, it looks like a negative 1, but remember, this is x minus h plus k, and again it's squared. So our h is going to be a 1, and this k is exactly how it is. So you take the opposite of that, and take that as exactly what it is, and our vertex is going to be 1, 4. We know that it's going to be a little bit, is it skinnier or fatter? Interesting. Does it open up or down? Go ahead and graph it right now over here in Desmos and see what happens to the red function as opposed to the blue one. Okay, if you graph the blue one, again, you don't have to put the f of x in. If you did, that's fine. I just put 2 times x minus 1 squared. Notice what happened here. Okay, we shifted to the right 1, because again, even though this is a minus h, it's a positive 1. We shifted 1 to the right, and we went up 4 from our original equation. And look, it got skinnier by a factor of 2. Remember, if we put in, let's say if we put this as a decimal, if we actually put this as a 0.2, it gets fatter. So decimals make it wider. Numbers greater than 1 make it a little bit tighter. Okay, let's go ahead and graph this next one. But before you do, I want you to take a look at this. This is now a positive 2. Remember, it's x minus h. So our vertex, so remember, it's going to be the opposite value. Our vertex is going to, because it's x minus h, it's going to be a negative 2. And then we've got a negative 7. Remember, the k is going to be just like it's seen, but the h is going to be the opposite because it's x minus h plus k. So our vertex is going to be a negative 2, negative 7. So it's going to shift 2 to the left and 7 down from our original function. Now, it's got a negative 3 on it, so it's going to go upside down. It's going to face upside down this time, and it's going to be a little skinnier or thinner than the 2. So go ahead and graph this into Desmos. Okay, graphing it, you see that it does open downward. It's a little bit skinnier than this 2 one here. It's 3. Remember, the bigger the number, the skinnier this is going to get. And our vertex is negative 2, negative 7. That's why this is called the vertex form, because we can identify the vertex in the actual equation. Notice that this graph does not intersect the x-axis. It has no x-intercepts. Now, before you put this into Desmos, this next one, to try it, I want you to identify what the vertex is. Remember, it's x minus h squared plus k. Identify the vertex first before you graph it. And tell me what it's going to open up or down, and whether it's skinnier or fatter from the parent. Again, the parent is the red function x squared. Y equals x squared, or f of x equals x squared. Okay, because of the negative 4, it is skinnier from the parent graph, and it opens downward because of the negative a. Our vertex is 3, 6, because our h value is 3. In the formula x minus h, it's a minus 3, so we take that for face value, it's 3, and 6 right here. There we go. As long as there's a negative sign here, the h is positive. It's a positive sign inside the parentheses, then the h is negative. Okay, in this example, we don't have an a value over here. It's actually 1, so it's the same. It's going to be the same width and same direction as the parent graph. But see if you can identify the vertex first, then identify all of these up here. Well, go ahead and punch this into Desmos first to see if you got the vertex of negative 5, negative 7. And there you go, negative 5, negative 7. Remember, your h is always the opposite sign of what's showing here, because it's x minus h. So if it's a minus 5, it's going to show up as a positive 5. So positive 5 here, it's actually a negative 5 and negative 7. Remember, the k value is going to be whatever it looks like here. The h value is going to be the opposite of what's in here. Now let's identify our x-intercepts. Here again, there's our x-intercept. Our x-intercept, we have to come up here to look at the y-intercept. There's the y-intercept. Don't worry about this dot here because that's just where it intersects the parent graph. If it weren't there, we wouldn't know. There's our y-intercept, 0, 18. Our x-intercepts are these decimals. We already know our vertex. Our minimum or maximum, it's going to be a minimum, right, because it's at the bottom facing up, our axis of symmetry is going to be the x value, or the x coordinate of the vertex. So our axis of symmetry is going to be equal to x equals -5. We already know our x-intercepts, our y-intercepts. Describe the transformation. It shifted left 5 and down 7. Okay, because it has no a, it didn't get skinny or anything. And again, our range is from our bottom y value. The range is going to be a -7 being the bottom and infinity being the top number. And of course, our domain, as with all domains, is -infinity to +infinity for the domain. That's what we're going to do for the next 2 slides. I got one more example for you that might throw you off when you see it. It's going to be this one because it doesn't have parentheses around it. It still is in vertex form. This is the actual vertex form because there is no 0. So if you need to rewrite it and understand that x minus 0 is still x, so it's just going to be a leave it x squared, and then we've got a -x squared here. Here, so our vertex is going to be 0, 1. And if we look over here and graph it, -x squared plus 1, and we've got our x-intercepts. So our vertex, our A, is 0, 1. This is looking up here at the number or the letters. Our B, it's a maximum. Our C-axis of symmetry is x equals 0. Again, D for the domain, it's -infinity to +infinity as all of them. E, the range, again, it peaks at y equals 1. So our top end is going to be 1, and it goes down. So our -infinity is our low number. 1 is the top number, and it can be included. F, describe the transformation. It just shifted up 1. Okay, didn't go left or right, just shifted up 1. Our x-intercepts are -1 and 1, and our y-intercept is 1. So for our last slide in this lesson, I want you to go ahead and go ahead and graph x minus 2 squared, and then also go ahead and do a -2x squared. Try to figure out, is there any k in here? No, it's not going to go up or down. There's no k here, it's not going to go up or down. Look, we've got a shift to the left, but do we have a shift to the left? And what's going to happen between these? Try to predict and then come up with the answers after you graph them. Again, I left the red y equals x squared up here as the parent function. Y equals x squared is the parent function, that's the basis. Okay, that's basically x minus 0 squared plus 0, with a 1 being the standard here. So go ahead and continue the video after you've graphed them. Describe everything, the vertex, minimum, maximum, axis of symmetry, etc. Okay, first we notice on the green one, we shifted to the right 2, because again, x minus h, that's a +2, we shifted 2 to the right. We didn't have a stretch factor because the a value here is 1, so it didn't look any different. It's not thicker or thinner than the parent function. However, this -2 not only made it a little skinnier, but it also flipped it upside down because our a is equal to a -2. Again, a times x minus h squared plus k. And for the green graph, we've got a minimum because it's the bottom. We know our vertex is 2, 0 because we have no k value. If we wrote plus 0 on here, that'd be our k value. The domain, again, like any parabola, -infinity to +infinity. Our range, however, stops because it's a minimum at 0 and goes to infinity up high. And our axis of symmetry, splitting it in a mirror image, is x equals 2. And our x-intercept is the same as the vertex. On the purple graph now, we've got our vertex at 0, 0. That way our x-coordinate is the axis of symmetry. That's going to be x equals 0. Our domain's the same. Again, look at the range now. Now it becomes a maximum. Okay, because it's a maximum and opens downward, our low number is negative infinity, and our top number, as high as the y value can go, is 0. And I got the bracket here because it includes 0. And this concludes our lesson. You're welcome to do the worksheets that follow this that are attached to the video. And if you have any questions, again, or find any mistakes, Easter eggs, go ahead and email me. Thank you.